sharing my screen now. If you see my screen, you see geometry, a right angle is formed here. So I'll just work through it. I haven't done, it's been a while since I've done one like this. So I guess if you have questions, just jump in. We'll see if that works for now. So I encourage you to take notes, but like I said, you'll have this at the end. Okay, so the area of the triangle as a function of x, you guys already know the area is 1/2 base times height. The base is, the base is some distance here based on this equation of this line here away. So the base, you're always going some distance x away. So base is really x, and the height of the triangle here is y. I'm sorry, let me not do that. The height is really y, but that doesn't help us much because we really want it as just a function of x. So we need to come up with the equation of this line here. And any idea how to do that, guys? All right.
Slope formula.
Slope formula. So we've got slope formula. We can just use these 2 points. So we can say the slope is like y minus 0. That's this y minus that 0 for x minus that 0. You might not think that helps, but it does. So our slope is y over x. So it's y equals y over x times x plus b, which happens to be y here. So maybe we shouldn't use those 2 points. Maybe we'll use like these 2 points over here instead, and we'll get the equation of the slope here as m equals 1 minus 0 over 2 minus x. 1 over 2 minus x is the equation of the slope. So we've got y equals 1 over 2 minus x times x plus b. And we can say that this goes through point y here. This is quite odd. Domain of the function. 1 minus 0, 2 minus x is our slope. Let's try another equation of a line here. So let's go with y minus y1 equals your slope 1 over 2 minus x, x minus x1. And let's use that point there, is that we have y minus 1 equals 1 over 2 minus x times x minus 2. So from here, I know we're kind of jumping around a lot, but we can actually rewrite this bottom here. The bottom is 1 over negative x minus 2. You can factor out a negative in both. The x's end up canceling. Y minus 1 equals minus 1. We keep proving the same thing here. Y equals 0. That certainly is not correct. You guys have any suggestions here? I'm running out of ideas on this one.
I'm also confused on that one. So
yeah, let me take a look here and see if I can figure out. We can find a solution here for this. All right. That is this one. All right, let me see what else I can find. It's odd that we're not able to just write the equation of the line and use it. Y obviously is not 0. And see if we can find another approach on this one. Okay, so let's see here. I'm trying to find someone that's already solved this because it's very unclear what the actual solution is. Everyone wants a video. We just want the solution. So let's see here. They use 1 minus y, 2 minus, okay. So they try this. Okay, so I think we can start fresh on this one. Let me just snip the problem in again, and we'll just do a reset here. Do you have a lot of problems like this on your assignment?
No, this is the only.
Okay. Okay, so this is a bit, I mean, this is a bit unusual, but okay. The slope formula, as you guys know, and we're basically using these 2 points here, and then we use these other 2 points because they're supposed to be the same. So if we use these 2 points, we have y minus 1 over 0 minus 2, and that's y minus 1 over negative 2. If we use these 2 points down here, we have 1 minus 0 over 2 minus x. So that gives you 1 over 2 minus x, and these are supposed to be equal. So if you set those equal, you get y minus 1 over negative 2 equals 1 over 2 minus x. Is that okay so far?
Yeah.
All right, so you can, believe it or not, you can solve this for y. It doesn't look great, but you can solve this for y. So you can clear this negative 2 by multiplying both sides by negative 2. You get y minus 1 equals negative 2 over 2 minus x. And then you can add 1 to both sides. You get y equals negative 2 over 2 minus x plus 1. It looks like they factor out a negative 1 from this to make it x minus 2. And that cancels with that negative up top. So the cleaned up version is 2 over x minus 2 plus 1. If we go all the way back to our beginning formula here, it's 1/2 x times y. Well, y is really all this. So we have 1/2 x times 2 over x minus 2 plus 1. And that is your area formula here. You can clean that up a little bit, but I don't know if it's necessary for you to do that, but that is possible.
Oh, that makes sense.
Okay, like some of the solutions I'm seeing here, they actually simplify this. So let me go ahead and just show you that in case your instructor expects you to see this. This 1 can be x minus 2 over x minus 2. So when you combine the numerators, see how that 2 cancels with that one? And you're just left with x on top.
Mm-hmm.
And then you get 1/2 x here. So it ends up becoming x squared over, and then this 2 goes with these. So you get like 2x minus 4 is the area function. Okay, so domain is the next part of this. That's a little bit tougher because you have to have an idea of what the graph looks like of this thing. Basically, there's a vertical asymptote at 2, and that's for x. So this thing does something over here, but essentially you should know that x cannot equal 2, but then like, well, what happens around it? So when x is less than 2, like sometimes you make a line chart here. I don't know if you're doing this in class, but let's say you put some breakpoints here. So what happens when x is bigger than 2? Well, you get a positive number here, positive number here. That's good. But down here, like let's say you pick 1. So you try 1. 1 squared is 1. That's fine. 2 times 1 minus 4 is a negative number. So this is negative. So this is bad. So your domain here is going to be everything bigger than 2 because of that. If that isn't clear, we can go through that again, but it's a little bit, this is a very challenging problem to start out with. So have you guys sent over anything else to look at?
I think I emailed you, I think 4
Great.
problems to do.
Great. So I heard Niko say he sent over some stuff. Got it. Thank you, Niko. Got it there. All right. In exercises 81. Okay, so which problems do you want us to do out of this grouping that you sent? Can you put those in the,
Let me
Can you
check
type-
the email.
or did you send them in the email?
I think I sent, did the pictures come through on the email?
They did.
Okay. Oh, so it should be the circled ones.
The
Like,
circled ones.
yeah.
Okay, so let's say starting with like 85. Is that right?
Oh, yes.
Okay. All right, let me see if I can get a good snip of this in here. So there are the two graphs, and then 85 is F inverse of G of 0. Okay. All right, so were you able to determine G of 0?
No,
Okay.
I'm just very confused.
Okay, so G of 0 is 2. We're looking at this graph on the right. It's basically saying, okay, if X is 0, what's the Y value? And the Y value there is 2.
Oh, okay.
Okay, so it's basically just like putting a number into a function. So this thing on the left here becomes F inverse of 2 because we found the inside part of it already. Is that okay? Like
Yes.
we're just substituting that. All right, great.
That's perfect.
So the inverse asks this question. It says, for what value of X is the Y value 2 in this case? So that's what we're trying to answer here. So it's like they give you the answer. The answer is 2. They're saying, where is the Y value 2? And the Y value is 2 over here at 0, which is a little bit awkward, but that's what it is. Okay, so this believe it or not equals 0, although this is not the best kind of answer. Let's just briefly do like, what is F inverse of, well, none of these other ones are labeled. So F inverse of -4, this is asking you, where is the output -4? What's the X value?
4. Okay.
4. And then like, what is F inverse? Let's do G because G's got a little bit of, what is G inverse of 6? So it's saying, what's the X value when the input is, or the X value when the output is 6? You can see that that's also 4 there. All right, so the next circled one that I'm seeing is 89. Is that correct?
Yes. Yes.
All right. Are you guys using, you're in pre-calculus, is that right?
Yes. Yeah.
Okay. Looks like a Stewart calculus textbook. All right. 89 here. So the instructions say to write the height of the rectangle as a function of X. Okay, so what they're trying to tell you is that like X is where X could be anywhere. X basically goes from 1 to 3. Okay, and when X is 1, Y is -1 squared plus 4 times 1 minus 1. Like that's just from this up here. That gives you the position there, and that equals 2. When X is 3, Y is 2. I think it's the output there, but anywhere in between, it's this right here, and that's what they're asking about. They're saying like, what's this height here? So the height is when we said 2 is really this distance from, let me change colors here. 2 is really the distance from the axis. The height is not that. The height is this like in between distance. Grab another color here. The height is this. So that piece in red is the total height minus whatever this consistent height is. Okay, so and I'm using a lot of words. It's not very clear. The height is like, let's just say X equals 2. Y equals -2 squared plus 4 times 2 minus 1. That equals -4 plus 8 minus 1. So that equals 3. But the height is of this piece is not 3. The height is 1. So how do we get 1? Because the output is 3. Well, you take the y value and you subtract 2 because that's this base here. So the height here is always the y value minus 2. And the y value is this function here. So it's minus x squared plus 4x minus 1 minus 2. And then you simplify that. If that wasn't clear, please speak up.
Let's see. So can you explain how you got the -2 again? I'm still
Yeah,
kind of confused.
I really don't like this example. Let me draw a much simpler one.
Okay.
To explain this. So let's say I have the equation y equals x plus 2. Okay. When x equals 0, what is the y value?
2.
2. Okay. When x equals 4, what is the y value?
6.
6. Very simple, right? Well, what we're essentially asking is I want this height right here. So let's go to x equals 2, y equals 4, but we know that this height is 2. Like we can visually see that. Well, why is it? But 4 is right there. So how do you get 2? Well, you have to subtract out this part down here.
Oh, okay. I see.
And so let's say I gave you a different graph where it starts higher. It doesn't really matter. You have to, wherever it starts, it's where you have to deal with this. So like here, it was just happened to be 2, but it very well could be something else. So let's say, I don't know, it's the equation 4y equals 4 minus x. So that looks like this. Okay, and we want the height right in here. So that's 1. So what do we subtract from the height? What is
1.
just 1? So the height would be 4 minus x minus 1. So you take your function, which is generally y, and you subtract whatever like the pedestal is, so to speak.
Okay,
Is that
makes
better
sense.
now? Okay.
Yes, thank you.
I skipped 83. We should go back to that. Is that right?
Yeah, the motor vehicle one. I think. Yeah.
All right. Use the table feature and feature. Okay. Are you guys using graphing calculators or using like Desmos? What are you guys using for
Graphic
this?
calculators.
Yeah.
Okay. All right. So I'm limited in my ability to show that because you can't see me. But essentially, we're going to enter this equation right here into y1 and this equation here into y2. And if it's not clear how to do that, I will talk you through the steps. I mean, it's not as good as seeing them, but let's see if we can do that here. All right, so you've got a y equals button on your calculator in the top left, hopefully.
Mhm.
You press that, and instead of putting t, you're gonna use x. So it's gonna be minus 6.13 x caret 2 plus 75.8x plus 577. That's in y1. y2 will be 24.9x plus 672. You do not have to graph this. Let me know when you guys get this entered in. I'm entering it myself, so I'll probably be the last one to finish. All right. So the next thing you're going to do is you're going to go second table. And in your table, you should see X, Y1, and Y2. Let me know if you don't. Okay, so if you're seeing that there, depending on how you have your table set. So if you go to second table set, that's another option here. Table set. It's another one of these here. You can either set the independent variable to auto or to ask. You probably want auto here. And if you need to change that, go back to second table and you'll see the values there in the table. So you only want to use the equation one from 0, 1, 2, 3, 4, 5, 6. These are good here, but then from 7 through 13, you're going to use the other side.
Mm.
You're going to use this one over here, and that's what's meant by this over here. This is a piecewise function. So that means that it's only valid in certain years. And so this question is basically asking you to enter the information into this table.
Okay, I got it now. Awesome.
All right, so that takes care of that. If you need me to give you the values, I have to go into another way of doing it, and I can do that for you guys. Or are you comfortable with entering them on your own, getting them on your own?
I think I'm comfortable doing it
Okay.
on my own. Yeah.
All right. 73, is that the next?
Yes. Yes.
Okay. Is there any more after this?
I think that's it. Just
Yeah, I
Okay.
don't have-
those.
All right, well, this isn't going to take us the rest of the time. So if you guys want to look for some more stuff or, jump ahead here, we can just show me what's in your next section. Be happy to help further. So, okay, the research and development department of an automobile manufacturer has determined that when required to stop quickly to avoid an accident, the distance in feet a car travels during the driver's reaction time is given by R of X. Are both of you guys driving?
No, not I don't drive and
Okay.
I have a
another
permit.
month.
Okay, so what this problem is saying, like you don't immediately hit the brake when you notice there's something wrong, like the car still moves. And sadly, I mean, this is what causes a lot of bad things on the road. So it's like your car is here. It's a terrible job, and you see something, like it doesn't matter what you see, but you travel some distance before you actually hit the brakes. This is the point where you hit the brakes. And you see this problem in physics a lot. So from here you hit the brakes, and there's another amount of time that it takes you to stop. Is that clear?
Yes.
Okay.
Mhm.
So the function that represents the total stopping time t is both of these together, because you go R of X, then you go B of X. So they call this the reaction time, and then the braking, or the reaction distance, and the braking distance. So in short, it's 3/4 X plus 1 over 15 X squared. So that's part A. Part B is to graph it. So you're going to want to put this in your Y1. I'm going to go use a more sophisticated graphing utility and help you guys out here with a nice picture. But you'll want to go replace those equations you had from the previous problem in your Y1 for this one. All right, so let me help you out here a little bit. Let me go X greater than or equal to 0. I'm going to snip something in so you can see it. So this right here is telling you your window. So you have like an X min, an X max, and then you have a Y min and a Y max, and that's under window. So if you hit the window button, you guys can grab that. So your X min should go from like 0 and your X max to 60. And then the Y is the more complicated one to tell you what it should be. Basically, it's whatever you get at 60 in this equation. So it's pretty big. Actually quite big. We go 250. Okay, so I think I've got a decent window here to show you guys what this looks like. I'm gonna snip this in so you can see. So your part B is to graph this. Let me make this a little smaller so we can see it in the window. So if you've never used Desmos, I like it a lot for these problems. It's much more visual than your calculator. So you're putting in y1, this 3/4 x plus 1/15 x squared. Okay, you can ignore that x greater than 0. So basically it's saying if you're not going anywhere, if you're not traveling at any, if x is 0, you don't have much, but at 60, down over here at 60, you're kind of all the way over here. So this is your x min, and this is your x max. And then your y min is also kind of down here at 0, but your y max is maybe at like 300. So if you're comfortable, try to change those values in window and see if you get something similar to this in that view. How are you guys doing on that? Any problems? Anything I can help with?
I have it in my graph. I'm ready.
Yeah, I just got it in.
All right, so Nico's got it. Nico, you using a TI-83, 84? What are you using?
84.
84. All right, one of the color screen ones.
Yes.
Great. Yep. All right.
Mine's in.
Jamie, how you doing over there?
I just got it in.
Okay, and you've got this shape, kind of got that. That's part B. So part C says which function contributes most to the magnitude of the sum at higher speeds? This is like one of those interpret questions that you see all the time in your classes. Basically, it's asking as x gets large, which grows faster? And your choices are x or x squared. Okay, and hopefully it's very clear that if you put a number in for x, well, you just get x out. But if you put a number in for x squared, you square it and it gets very, very large, much faster. And if that still isn't clear, think of what the two graphs look like. That's y equals x, and that's x squared, and y equals x squared goes really fast compared to x. So the answer is the b of x function, which is 1/15 x squared. And then the explain, what they're looking for is a sentence where you say something about how one function is faster growing than another, something like that. And I'll leave that up to you guys to sort out. That way I don't write something that you both put down.
Okay.
If you're submitting this on your own. So something that just says that, x squareds grow faster than x. I know they have coefficients, but that actually doesn't matter, believe it or not. All right, do you guys have some other things you want to send me? Nico, Jamie?
I'll look
Um,
through some stuff.
Same. I'm just gonna grab my math book real quick.
Okay. Let's spend a few minutes. If you guys can't come up with anything, I've got a question of the week, SAT, ACT prep we can look at.
That
Got some other
works.
things too. So, but yeah, I would encourage you to take a minute or two here. I'm just gonna mute myself. I'll come back in a minute or two and you guys let me know if you you see something else.
Okay.
Okay, I'm back.
What was that?
I just grabbed my textbook. So I'm
Okay.
back.
Anything coming up there or anything?
Nothing for me, I think.
Okay.
I think all the questions have been answered for me.
Yeah.
Okay. Are you guys planning to take the SAT, ACT? Have you thought much about that?
Probably will take it.
Yeah,
Yes, same here.
it's a little uncertain. Some colleges aren't requiring, but let's just assume for the moment they are. This question is designed to be solved in under 60 seconds. I won't, mandate that you do that right now or require that, but that's kind of your goal here. So let me snip it in and you guys can take, 1 to 2 minutes here and see if you can solve it. Try to take a step in the direction of solving it, and I'll stop talking here while you guys give that a look over. And why don't you guys just chat me the answer you get, and not say it out loud, just whenever, if you get to it. If you get stuck, that's okay. We'll work through it.
Okay.
All right, anybody got an answer here or close to it?
I'm just about finished.
Nico, how are you doing on this?
I got an answer, just not one of the options.
Not one of the options. Okay, never
Yeah.
good. Never good. Okay. All right. Well, let me post the solution for you guys in here so you can see it, and then maybe you'll see something for that.
Or -30.
Jamie, how did you do on this?
Is it -30?
It is. It is D. Yeah.
I made a bunch of mistakes on the way, but corrected them.
What would you say was your main mistake? We're not being critical of you, but what did you find was challenging about this?
The first thing that I did wrong, I squared
Instead of
X.
cubed? Okay.
Yeah, instead of cubing it. And then the second thing I did wrong was I had DS3 when it was 2 in that second equation.
Okay.
Yeah.
Niko, anything you want to express here that you found challenging, or where you see a mistake might have been made?
I didn't put the 5 on the other side. I don't know why, but on the first part, I just plugged in everything, but there was no.
Sure. So there's nothing inherently difficult about this particular question, but it's a lot of things that you might have to do together. So what's nice is I'm going to give you one just like it, but with different numbers, and give you guys another chance here. This should go a lot faster for you. Are you guys both ready to do one more of these?
Yeah, sure.
Okay. Both get a confirm from you, Jamie?
Yeah, I'm good.
Great. Here we go.
All right, I'm good.
Okay. Can you chat me your answer? Just do it to me, not to everyone, please. Okay. All right. Thank you. Jamie, how was this the second time through? Was it easier?
Yeah, it was easier.
And why was it easier? Just because you knew what the steps were, or what?
Yeah. I just didn't have to think about the problem as much. And that allowed me
Right.
to focus on getting everything right.
That to me tells me like you're good at the mechanics, like the I can cube things, I can solve, I can do that. Believe it or not, you this is kind of a standard question you might see on SAT. It's not overly difficult, but you have to know what to do. You have to be comfortable doing the steps. Niko, how are you doing there on this?
I'm stuck on one part.
All right, so let's do this. Let me just would it help you to see the solution, or do you want to ask where you're stuck? What would you prefer?
Probably the solution.
All
Or
right,
just
let
like
me
the steps of finding a solution.
yeah, I have the steps here as well. So let me snip that in. What did you get for a value of A before I snip this in?
My value of A was, I don't even know, like
you
really
don't know.
far off. It was,
Okay,
I
okay.
stopped because I realized that it was
All
not
right.
close.
All right, here we go. Yeah, A is the intermediate like checkpoint on this one for you.
Okay, I see now.
Yeah. So what you're finding in these questions is there's a lot of synthesis, which is that fancy word they like to use for like a couple of concepts together, and a lot of misdirection. If it told you to do these steps, you could do it, but that's not what this test is for in the SAT ACT. It's much more, I don't know, confusing, we'll say. Anything else come to mind, guys, on stuff you want to look at for your class? Anything else you can remember? We got a few minutes left here. Would anything else help you?
I think I'm fine. Yeah, I think so.
I should be good.
Okay, so just in case you guys were wondering, if you go to tutoringbymatthew.com, I post a new question every week with the full solution. Great for SAT, ACT prep, and I'll always pull one into the lesson if we run out of stuff to work on. Just good practice. So thanks for your time, guys. I'll send out the notes and the screen recording out shortly, and I'll see you next time.
Awesome. Thank you.
Thank
All
you.
right, have a great day. Bye now.